Okay, so this lesson we are going to talk about solving quadratic equations by factoring. And we've actually sort of already done this before. What we're looking for is solving what we are doing when it says here solving a polynomial, but any equation, when you are solving, that means you are determining the value for the variable that makes the equation true. Even if you have something simple like 2x equals 6, then you're still finding a variable where 2 multiplied by something is going to be equal to 6. And we call the solutions the roots of the equation. And so we spent a lot of time with factored form in Unit 3 for this day because the roots of the equation are essentially solving for the x values that make the equation for y equal or true. And so there was actually people who asked me about this. You tried to set y equals to 0, and then you were like, well, how do I do this? Or if it was standard form, I have two instances of x. How do I find what those values are? And now we have a strategy. We know sort of what to do. Okay, so when you had last unit, when you were going to find the roots, then whatever was inside the brackets, you could have set it equal to 0 and solved, or isolated the x value. And what happened was inside the equation, if it was a negative, it changed to a positive and vice versa. If it was a positive inside the equation, it would have changed to a negative value. And once we had the roots, then you could find the vertex. So we are going to need the vertex this time because the vertex gives us the optimal value or the max or min, which is the y value of the vertex. Okay, so in general, the x value of the vertex, you add the roots or the zeros and divide by 2, and then you sub in x and solve for y. So really, in a lot of ways, this was the most amount of algebra you had to do in Unit 3 was add the roots together, divide it by 2, and then sub in the x and solve for y. But you would have already had the equation similar to, similar to this example here. Okay, so whatever, however you would like to, however you would like to uh, write the roots or solve for the roots. If you got good at last unit, just writing x equals -2, x equals +4, all you had to do was change the signs. That'll work here. Or if you solved for the roots, like I just did above, which is always okay, x plus 2 equals 0, x plus 2 minus 2 equals 0 minus 2, in the end, you get the same answer. Okay? And so then once you have the roots, the x value of the vertex, you add them together. And divide by 2. So negative 2 plus 4 is positive 2. Divided by 2 is 1. And then wherever you see a 1, you're going, or sorry, wherever you see an x, you're going to put a 1 and decide for yourself how many steps you need to take. So 1 plus 2 is 3, 1 minus 4 is negative 3, and now we have negative 2 times positive 3 becomes negative 6. Negative 6 times negative 3 is positive 18. So now we have a vertex, and I'm just gonna sketch 1 and 18 is way up here, and the parabola opens down because of the negative value. Okay, and so this is a maximum. And when we do our word problems today, what you're going to see is many of them are going to be modeled by this sort of parabola. And there was a question on the Unit 3 test about subbing in variables, and some of you got tripped up a little bit. So when you have the way that we write standard form, for a quadratic equation, this means that this y value, whatever you write on the left-hand side or whatever you equate the equation to, is going to be the what goes on the y-axis. So whether it's height or area, profit, any of those, and then what's on the x is going to be in the horizontal direction. So often time or a length, something that is easy to measure and control. Okay? So you can do questions sort of similar to the one above, where you're already given the equation. You could, now that we know how to factor, we can deal with that. So we can factor first, but if you're given the factored form like you would have been in Unit 3, then finding the roots is not so bad. Okay, but if you have to factor first, so when it says solve, and usually, because we're going to do another way of solving later, it'll say solve by factoring, and then of course the check is more like what we did in Unit 1, left side, right side. Okay, so when you're solving the equation, what that means is we are going to set y equal to 0. So I'm just going to show you all of our examples. Equals 0, equals 0. Even the word problems, we're going to find where it's equal to 0. Okay, so that's a very common way to attack these problems. We're going to set each factor containing an x equal to 0. So that's why when you have standard form, that's tricky to do. And when you have factored form, like in the third line here, then it's a little bit more straightforward. So this factoring out, so first we had to common factor the negative 7. And then even still, that's not a simple trinomial to factor, that's a complex. So you could have done box or guess and check or decomposition to try to find two numbers that multiply to 18 and add to negative 19. Okay, and you would have ended up with these two binomials. So you can set 2x minus 1 equal to 0, x minus 9 equal to 0, because if you have either of the brackets as 0, then when you multiply, whether you multiply -7 times 0 times a million, or -7 times a million times 0, who cares? Both of these are going to be equal to 0. So as long as even one of the sets of brackets is 0, then our equation will be 0. So this one over here, this x minus 9, that's more like what we're used to. We just have to change the sign. But this one over here on the left, we're going to have to solve. And this is why solving is actually maybe a little bit more straightforward. So I'm going to get rid of the 1 first. But now I also need to get rid of the 2. So when you write 2x, that's multiplication. So the inverse of multiplication is division. So 2 over 2 becomes 1. And then you can write the x as 1/2 or 0.5. So we don't always have to have a nice, perfect parabola, but or a nice perfect whole number, sorry, but hopefully for now the decimal place values are such that it's not going to be a repeating decimal. Half or 0.5 is not a bad variable to deal with. So we're going to check the answers. We're going to check both. Okay, so we're going to check back into the original. I'll do the nasty one first. Do the right side. And remember, sorry, that's left side. Our right side is going to be 0. So that is a pretty easy value to check. So even if this seems like an insane equation to put into your calculator, you're really looking for 0. So have a good relationship with your calculator. Figure out where the 0 is going to be, or sorry, where the brackets need to be. You can show all of your work though. 0.5 squared is 0.25. 133 plus or times a half is going to be 66.5. It is not an even number. -14 times 0.25 is -3.5 plus 66.5 minus 63. So when you add those together, you get 0, which is equal to the right side. Fantastic. 9 is a whole number, the other 0. Nines are nasty. So again, I'm not going to ask you to, or I'm not going to expect you to use mental math. So if you forget what 9 squared is, that's fine. It's 81. Even 14 times 81, I don't know what that is. 133 times 9 is 1,197. The 63 has no x variable. -14 times 81 is negative 1,134. It seems like a big number, but remember, we're trying to get to 0. So once we did 133 times 9, we were pretty sure that it should be quite a high number. Okay, so we're going to solve these two and check. So again, this kind of goes, we had to do the reasoning lesson first because you need to decide what kind of factoring you're going to do. So in this case, this is simple. This is a simple trinomial. A is 1. Still, if you want, 24 is a number that has many factors. So if you want to do the chart to check it, Sometimes maybe it's not a requirement. So what do we got? 124, 212. That's not going to get us to 3, 8. We're getting there. That's going to be 5, 4, and 6. Okay, so if we did, uh, they, one of the numbers has to be negative because it multiplies to a negative number. So if we did -4 and +6, you would get +2, but we want -2, so it's going to be +4 and -6. I wrote the +4 first, that doesn't matter. Okay, but then this time, yes, we need to factor, but we also need to solve. Okay, so we are finding those zeros or the x values. And when we do the word problems, you'll see why in a second. Okay, so maybe for this kind of equation, you could just write the number in the opposite sign, but again, even the next one we're going to do is a little bit tricky. Okay? And then we're going to check both x values in the original. So -4 squared minus 2 times -4 minus 24. So that's 16 plus 8 minus 24, which of course is 0. Sorry, I'm almost out of room. Uh, +6. So 6 squared is 36, minus 12 minus 24, 36 minus 36, which is 0. I just did that math weird. It actually doesn't matter. You could have done 36 minus 12, which is 24. 24 minus 24 is 0. Okay, so this is a special case. It's only got 2 terms, so hopefully that is your reminder. It's going to be a difference of squares. Okay, so I'm going to square root the 9 and the 25. So 3x plus 5, 3x minus 5. 9, square root of 9 is 3, square root of 25 is 5. And then don't forget, we are solving. So 3x plus 5 equals 0. So again, this is a case where actually setting it equal to 0 and solving for that x value maybe is something that you want to consider. Okay, so 3x minus 5. First, I'll move over. Oops, sorry, I cheated there. Got to show all my work, don't I? Plus 5 minus 5, there we go. Okay, and then divide that 3 out. And because we don't have to do anything else with that, I'm going to leave that in there, like a uh, number like that, 5/3. Okay, so there we have one positive root and one negative root, which makes sense when we have a difference of squares. Okay, so that's not such a nice number. It is a bit of a repeating decimal. And so then it doesn't really lend itself well to creating a perfect number. But what happens when you go to check, so this is where having a really good relationship with your calculator is a good idea, because what happens is the number becomes so small that it actually works out to zero. And when you square a negative number, your answer becomes positive. So in both cases, it's going to work. Okay. All right, so here's a question. And again, like I said, on the Unit 3 test, there was a question about height and time. Okay, so remember that when you have an equation, even if it's written like h equals negative 5t squared plus 30t plus 80, you're going to write y equals, or think of it, sorry, as y equals ax squared plus bx plus c. So the value here is the y value, and the value here is the x value. And that does make sense. If you make a graph, then usually time's on the x and height's on the y. We are controlling the time. How often are we measuring the height? Okay? I know you do that in science class as well. So then, how long does it take for the diver to hit the water? When you have a word problem, we're going to think about two things that are logical. So if it hits the ground is going to be, or hit the water in this case, sorry, the ground is going to be a height of 0 meters. Yes. And you can't have, you can't have negative. We are assuming the diver, this human being, is not going to drill itself through the ground, right? That's not a thing. Second of all, when you find a root of a quadratic equation, you often, not always, but you often get a positive value and a negative value. And when we're just talking about random x values, who cares? If it's 6 and negative 4 and positive 6, whatever. But when you're dealing with time, you cannot have a negative time. We cannot go below 0 time, at least not now. Maybe one day in your life will you get to go backwards in time? Maybe, but certainly not now. Okay? So in A, we're going to look for how long it takes the driver to hit the water, the diver, and we're going to make sure that the route or the time that we choose, that we are choosing the one that makes sense. And then we're going to solve for the diver's maximum height. So yes, where the diver hits the ground is going to be important, but also its maximum value. So that's why we reviewed how to find the vertex. So in this case, in order to find the vertex, in order to solve the equation, we have to solve by factoring. We need to find where those roots are, and right now we can't do that. Okay? So when you have a question like this, when it's a motion question, like something has been thrown, the diver's throwing himself, kicking a soccer ball, any of those, then what you're going to find is often the equation has a negative 5 in front of it. Those of you that are science buffs, the acceleration due to gravity is 4.98. And so we round it to 5 for now. Eventually, to be honest, we're going to use something that we don't have to round. So we could deal with the 4.98. And the reason that it's negative, of course, that means the parabola opens down. And why is motion on Earth down because of gravity. So when you get to physics, they'll talk about in the down direction. That's a vector quantity. Okay, so you're going to see this -5 in many of these equations. So if you take a look at the numbers, 30 is divisible by 5, as well as 80, I guarantee that is going to be one of the first steps you have to do. We need to common factor the -5 when you're solving by factoring. Okay, and the equation is describing motion. So at first it looks like A is not 1, but when we divide out the -5, watch what happens. Now A is equal to 1, which makes our life easier. And we don't have to use the complex factoring methods. If you do not love H's and T's, I saw some of you on your test, you converted it into Y's and X's. That's fine. That's no problem. But when we get our answer here, we have to think about which one is going to make sense. Okay. So I am going to make my little T chart. Now we are looking for two numbers. Actually, I don't even need to write A, right? Two numbers that multiply to 16, -16, sorry, and add to -6. Okay, so 116, no, 2 and 8. Oh, yes. So 2 plus 8 would give us 10. That's not what we want. If you had -2 and +8, that would be +6. Not what we want. But +2 and -8 is going to give us -6. There it is. Okay, so considerably less work than the box or decomposition. So we have t plus 2, t minus 8 are our two factors. So now we need to do the solve part. So t plus 2 equals 0, t minus 8 equals 0, plus 2 minus 2 to get rid of it. Okay, and now we have these two time values. So it says, how long does it take for the diver to hit the water? And you might be like, well, Miss Todd, there's two times. Which one is correct? And again, this time value, -2, is inadmissible. Time cannot be negative, at least not in 2024. That means that the time it takes for the diver to hit the ground or hit the water is 8 seconds. Okay, so that is solving by factoring. And then B, actually, I'm going to draw an arrow up here. B, we we don't need to factor. We need to solve for the vertex. So to find the maximum height, we need to solve for vertex. And it would be nice if we could solve for the y value first, but you can't. Okay, so we have to do B after A because we do need those roots. So the x value, you add them together, or the t value, sorry, if you prefer that, that's fine. Negative 2 plus 8 is 6 over 2, which is 3. And then I'm going to sub t equals 3 to solve for h. And you know what? I'm not even going to write y. I'm going to write h because it asks us for the maximum height, which is h. Yes, they are the same, but let's give it a go. Let's try not to write x and y because we can do it. I'm proud of us. Uh-oh, I'm out of room, sorry. Okay, so negative 5 times 3 squared, so you do negative 5 times 9, which is negative 45, plus 90 plus 80 is 125 meters. No, that's quite the height, but that's okay. We will trust that our diver is incredible. So I'm going to sneak in a little sentence. Therefore, the diver's max height is 125. 125 and then meters because it told me in the question height in meters. Okay, and I want to write a good sentence. Okay, I like this question. So the area of a rectangle is given by the equation area equals 6x squared plus 5x plus 1. Determine the binomials for the length and width of the rectangle. Then calculate length and width and area if x equals 4 centimeters. Okay, so when we have area, you're used to area is length times width. This is multiplication. So in here we are multiplying, right? Which means that you can multiply anything, even if it has two binomials. So that's what we're going to do. We're going to factor this equation and we will have the binomials. And in this case, we actually don't even need to set it equal to 0 because it's told us what to use to solve our equation. Okay, so this is a different kind of question again. But now our trinomial, this is complex. Okay, so A is not 1 and there's no common factor. So we have to either use decomposition or box to solve for this, whatever you have been using. Either way, really, we still need to find two numbers that multiply to AC, which is 6, and add to positive 5. And actually, I'm going to shorten my little chart here because 6 is either 1 and 6, but since 5 is positive, it's going to be 3 and 2. Okay, so that is pretty straightforward. So maybe this time you would want to either guess and check, oops, or not use the box, use decomposition. It's up to you. All adding, yay, that makes our life wonderful. Okay, so I'm going to group factor these two and these two terms separately, creating something in brackets that is the same. So I'm going to do, in the first one, I can divide by 3x. Oops. And I'm left with 2x plus 1. And then remember when you already have what's inside the brackets, so the next two terms are 2x plus 1, that means that we're going to common factor out a plus 1 so that our two brackets are 2x plus 1, 3x plus 1. The beauty of these questions, it doesn't really matter when you multiply length times width. This one could be width or this one could be length. It doesn't matter. When you multiply, the order doesn't matter. So that is why I kind of like this question. So it says determine the binomials for length and width. So, I mean, I'm pretty lenient. You could leave your answer like this, but then you could also have a sentence, length equals 2x plus 1, width equals 3x plus 1. That's fine. When you solve for length or width, just make sure you have units, and then area, of course, should be the unit squared. Okay, so this time we have centimeters. So 2 times 4 plus 1 is 9 centimeters for length, and width is 3x plus 1. 12 plus 1 is 13 centimeters. So then area is length times width, 9 centimeters times 13 centimeters. So when you have a common base, you add the exponents, okay? So 9 times 13 is 117, and then centimeters squared. And again, you could have done this the other way around, calling the length 3x plus 1 and the width 2x plus 1. That doesn't matter. Okay, so give some of these questions a try. They're all different kinds. Yes, some of them say tough. Give those ones a try, okay? And see what you get. Okay, thank you.